Hello, this is Peter from OneCNC UK, and what we're going to focus on in this video is the differences between OneCNC XR5 Professional to the latest version release of OneCNC XR7 Professional. The first thing you will notice is OneCNC XR7 is now a full 64-bit install, providing your computer has a 64-bit Windows operating system. However, you can still install as a 32-bit application if you want to. The obvious advantages of using a 64-bit is that you utilize more of your hardware, which will translate to toolpaths being calculated quicker and things like that. Another great new feature is backup file archive. If we head over here and select backup file archive, what this does is take multiple snapshots of whatever time interval you set up throughout the progression of the part, not only for geometry, but also for toolpath creation. So what that enables you to do is if you have a power out situation, for example, you can go back to anywhere during its creation and reload the file. This is a huge change from XR5, as this version only took a single snapshot, so a great enhancement to the software. Okay, so let's have a look at some of the differences in the toolpath. So we'll have a look at pocketing. This is a traditional pocketing cycle, so we'll just go into Edit and have a look. The first thing you will notice is there a new dialog box for flute length. The reason for this is if you are making a pass that is too large for the flute length, you can configure your simulator to warn you that you are exceeding the parameters for that tool. In fact, the entire tool and holder are now collision detected within OneCNC XR7. Another thing you'll notice is that within XR7 we now show your import model inside the clearance form, and these coloured grids all represent the different clearances and depths. Rapid plane is represented by the red grid, plunge clearance is represented by the black corners, material top is this grey boundary, and final Z is blue. So this is giving us a good visual representation of all our settings. So we'll select next. We're going to look at traditional, and you'll notice there's a new option for lift between cuts on last depth. Now OneCNC, when using traditional, makes concentric cuts heading towards the center of the pocket or from the center of the pocket out towards the boundary. And the link between those concentric cuts is just a diagonal movement from one to the other. In XR5, it would possibly leave scallops marks. In XR7, the tool can lift off the base and then ramp down to the next cut. So we'll just push through this form and we'll zoom in and we'll have a look. And as you can see, when the tool finishes its one pass, it lifts up and then ramps down onto the next face, leaving you with a much better surface finish on the base. And this particular option is available for pocketing cycles and also facing. Another thing you'll notice, if I just go back into Edit and push through this form until we get to the settings, you'll notice the step over distance is now set to 95%. Well, in XR5 we recommended no more than 60, possibly 65% because of the chance of leaving upstands. Well, in XR7 it has now been completely revamped, and if I just go into simulation, we're going to simulate to a stock model, and you'll see as it works its way around, it leaves no upstands whatsoever. You will also notice that we are now able to simulate with multiple stock models. This is a great enhancement in XR7 because it now allows us to collision check our entire setup on the machine, whether it's straps, whether it's cap heads, whether it's side stops. The whole tool and tool holder are now collision detected, so a massive change from XR5. So let's have a look at collision detection. I'm just going to run our mill profile operation. Still working to a stock model, and we'll just increase the simulation time. You will also notice that OneCNC XR7 now has 100 times speed operation, so it enables you to run through the simulation far quicker. So as you can see, that toolpath went through there with no issues. So let's make a couple of edits. We'll just tell it that our flute length is, say, only 15 millimeters long. We'll push through to the end of the form, and again we will resimulate this toolpath. So straight away you can see you've got a collision detection alarm. If I press play, you'll see obviously visually there is way too little flute length to do this, and as soon as I carry on the simulation just by pressing play, you can see that it now paints the model as to where you have the issues. So wonderful visual representation of everything that's going to happen on your machine. Let's have a look at another type of collision problems. Let's just put the flute length back to where it was, and let's say for instance I didn't give ourselves enough clearance to avoid the straps. Again, we'll just push through to the end of this form. We'll simulate rest, and as you can see now the flute lengths are no longer an issue, but there we have one. Red alarm, rapid collision detection. Obviously we need to sort that out, but just so you can see what happens, it actually takes out anything that is in the way. So you can see straight away on your machine setup you have got problems that you need to avoid. So again, we can just go straight back into our mill profile operation, go back into edit and set it at a safe distance. So a great representation of everything that's going to happen on your machine tool. Another major enhancement within inside OneCNC XR7 is Drill Hole Wizard. Drill Hole Wizard now gives the ability of machining holes on different levels. So whereas in XR5 you would need to spot drill the face on top of the 10mm plateau and then use another toolpath to spot drill the holes at Z0, you can now select all the holes. The big difference being you just need to extract the edges off the holes to be able to use this function. So let's go into edit. We've already selected the holes that we want to machine. There is our use geometry for material type option. Clearance form as normal. Center drill, drill, tap, whatever operations you need to perform. And if I just run this through in simulation, you'll see it's now doing the spot facing and the drilling on multiple levels. So again, a great enhancement, saves a lot of time programming. Again, only available in XR7. So let's carry on and have a look at a few more enhancements within inside of XR7. OneCNC XR7 now uses the OneCNC Active Cut. This is a feature which is designed to improve your toolpath efficiency, dramatically reducing your cycle time, hence increasing your machine capacity. So let me give you an example of how this works. Obviously, the most restricting part of any toolpath is when the tool has to enter sharp corners or small rads. You might be able to cut this part quite easily at 500 millimeters a minute, for example, on the linears or the large arcs, but when it comes into these small corners, you might need to reduce 50% down to 250 millimeters a minute. So you'd need to run your entire program at 250 millimeters a minute. OneCNC now gives us the ability to look into corners and slow down. So let me give you an example of how this works. Okay, so if we go to high speed pocketing, we'll just select these three pockets. We'll just stick with the same tool, and as I say, If we had to run at 250 millimeters a minute because of the tight corners, we will do the first program at 250 millimeters a minute. We won't be using the feed control until the next toolpath, just so you can see the difference. We'll just push through this form. You will notice there is another toolpath involved now in XR7, high-speed zigzag. We will go back and have a look at that feature later. And you'll also notice you now have selected entry position. Again, when we finished going through this particular option for active cut, we'll come back and have a look at these two other options. And we'll just, as I say, push through this form and finish it off. So there is our first toolpath. So if we just have a look and see what the cycle time of this is, we'll just go into post operation, select job sheet, and you can see we've got an approximate time of 50 minutes. That is running, as I say, with the feed rate, enabling the tool not to squeal going into corners. So let's have a look and see how active cut affects the cycle time. So we'll go back into this program and edit. We'll now bring in feed control. We'll just activate the look ahead, and this gives you the ability to look into corners, and you can either start looking into corners as a percentage of the tool or manually input it in millimeters. So for this example, we'll just stick with the default at 25%. And obviously we only need to slow down on the small arcs. We don't need to slow down on the large arcs. So this gives us the opportunity to search for different size radiuses. And again, you can either do it as a percentage of the tool or manually. So we'll just leave the 25% active. Now, as I said, if we could cut on the linear moves at 500 millimeters a minute, but we need to slow down into the corners to 250 millimeters a minute, our feed rate reduce would be down to 50%. And we'll just select OK. You'll see now feed control is now being used. So I can ramp up my linear moves to 500 millimeters a minute. And again, we'll just push through the form, leaving everything else exactly the same. So let's compare cycle times. If we go back into post operation, select job sheet, you can see we've now reduced the cycle time by 50%. This is going to save you an awful lot of time, increasing the capacity of your machines, and also running the tools at the correct speeds and feeds, you get better tool life. Now, as you saw when we were going through these forms, there's also a few other options available. So if we go back into edit operation, we'll just go to our toolpath styles. And as you can see, there's a new option called high-speed zigzag. Again, this toolpath uses active cut technology, allowing you to slow down. But the unique thing about this toolpath is you can see just about, I will show you better when we actually run the toolpath through, the tool actually drops down, re-engages on the linear or arcs, and removes all the cusps around the profile. So when you go around with your finish tool afterwards, you've got a constant cut, not going thick and thin, giving you a better surface finish. So we'll select high speed zigzag. Just for this example, we'll plunge in, maybe change the step over to 50%. Let's just ease off on the peck depth. Let's go for 12 millimeters. And again, we will just push through the form to finish. So let's see what this active cut is doing to this zigzag toolpath. So we'll simulate this toolpath and have a look and see what it does. So if I just zoom into this area, we'll just leave the toolpath to run for a few seconds and then I'll slow it down. Okay, so when you see it approach the linear wall or the radius, speed it up a touch, you'll see it actually drops down before it reaches the wall, radially arcs onto the wall, and then continues up to take its next step over. So, as I say, you end up with a nice smooth wall, no cusps for your finishing toolpath to go over, giving you a much better surface finish. But as you can see again, you can see it ramps off, radially arcs back on, and continue machining. So a very nice, efficient toolpath. Another feature they've introduced is giving you the ability to force your tool to start exactly where you want it to. You might be doing this because you've pre-drilled a hole before it goes off to heat treat, or you might be doing it because you're working with a casting and there's a specific position you wish to plunge in. Well, as I say, now you can control where the toolpath enters, and all you need to do is put a circle on the screen where you want the tool to start. So let's say, as I say, this is a casting. You might have a hole in it there, might have a hole in it here, and also down at the bottom. Now, as I say, this works for single toolpaths, single pockets, or multiple pockets. So we'll just go in and edit this mill pocketing cycle. We'll just push through this form again. We'll just go back to high speed close just for this example. And because we're plunging in to either a pre-drill hole or a casting, we can obviously select plunge. You then get an entry position. Automatic, obviously OneCNC would just calculate the most efficient place for it to start. We want to force the tool to start in a particular area. So we're going to select an entry position. Again, we'll just push through this form to the very end, and the prompt at the bottom of the screen asks you to select the circle for your entry. So we just simply left click on the entry points and it will recalculate the toolpath. And if we zoom in so you can see, the tool is actually plunging right on to the center of those 3 holes that were in there. So again, another method of increasing the efficiency of your toolpath. Another feature is you can now control the ramp diameter of your tool. Now, as you're aware, in the previous versions of software, you're restricted to the size of tool when using ramping helix options, because OneCNC would default to basically creating a diameter which is almost twice the size of your tool. So you were limited on the size of tool that you could actually start removing material. So let's give you an example of how this works. Let's just put a quick rectangle on the screen. Let's say we'll go for a length of 30 and a height of, doesn't really matter for this one, 80. Now, because we've only got a 30mm wide groove to get into, as I say, in previous versions of software, you would have to be limited to your diameter of tool, possibly a 12mm diameter. In the new version of software, it will allow you to control the ramp helix that you create entering. So that gives you the ability of going with a larger tool to remove all the swarf much more efficiently. So let's just open up our stock toolpath, select the boundary again, and let's say we want to machine this with a 20mm diameter tool. So let's just drop a 20mm tool in there. Okay, let's say we're going to go 10mm deep. We'll still stay with high speed closed. We're going to use ramp helix because we're going into solid. As we're going into solid, I'll let OneCNC calculate out the start position itself. And as you can see, you've now got a minimum ramp diameter and a maximum ramp diameter. So let's just pop this back to what the maximum was, which would be your original default in XR6 or previous versions. And we'll just push this form all the way through to the end. Could not generate your toolpath. Check your settings. Now, this is obviously down to the fact that your tool is oversized. So let's go back and recalculate this toolpath. So we'll just again go through this form, and as you can see, minimum and maximum ramp. So I'll just set this to a minimum of 5, accept the form all the way through to the end, and now you have a more efficient toolpath using a larger tool to get rid of all the material as quick as possible. Again, if this was a casting and you needed to force the tool to start in a particular area, you could just pop yourself a circle on the screen wherever you wanted it to start, recalculate your toolpath, select entry position, and then finally just select the entry position. And as you can see, if I just spin that round a bit, you can see the tool is helically ramping into the start of that hole. Obviously, to make the tool more efficient as you are feeding into a hole, we could then change that over just to a simple plunge. And there we have the start point exactly in the center of that circle. So let's recap. We've got active cut, high-speed zigzag, custom entry position, ramp helix options, all very powerful tools available in all versions of our OneCNC XR7 upgrade, also available in 3D toolpaths. Again, dramatically increasing your machine's efficiency, capacity, and tool life. So the next thing we want to have a look at is Smart Selection. Now, Smart Selection is a brand new feature in OneCNC, and it's there to assist you in finding errors in customer files. So I'll just open up a quick example for you. So when you've loaded in your CAD file from your customer and either trying to create a toolpath in the profiles or maybe turning that wireframe into the model, you realize you've got a problem. So for example, if we go into extrude and we try and select this profile to extrude a boss, you will see it's only following that geometry part of the way round. So you know you've got straight away either overlapping entries or duplicate entries, because if you try and create that as a model, it obviously hasn't got all the way around. Again, similar thing if you're going to create stock toolpaths and possibly high-speed pocketing. When you select the profile, you can see it's not tracking that profile all the way around. So again, you know straight away you've got problems with that geometry. To help, so let's just have a look and see how that works. So if we go into Smart Selection now and just activate the form, you can see it allows you to search for duplicate entities, overlapping entities, by connections, by type, by diameters, by length, by Z positions, by width, and by properties. So there's an awful lot of very powerful tools available within inside this. So we'll start off having a look for duplicate entries. Now, duplicate entries are complete copies, a full arc, a full line, and as you can see straight away, it's found a full arc going around this section of the profile. Now, they might do more than one. There might be 3 or 4 copies underneath there. OneCNC will have picked all of those up. And if we have a quick look for overlapping entities, you can see these are the partial profiles that it's managed to pick up. Now, as I say, very quick, very efficient. So once we've found those duplicate entities, we just simply select OK. They will remain highlighted, and then we can simply delete. Once you've deleted those out of the way, if you go back into high-speed pocketing, you can obviously select the profile. It's all connected up, so we can create our toolpaths, or if you're going to turn it into a solid model, let's have a look at the quick access toolbar. Not unique to XR7, it's also available in XR6, but it becomes a little bit more relevant when you're working in XR7. You can then collapse these areas on the right hand side of the screen and the left hand side of the screen, giving you a much larger programming or modeling area. So I do hope this was helpful, and if you do have any questions, please get in touch with OneCNC UK. Thank you very much for watching, and hopefully we'll speak to you soon. Bye bye.